In this video, we'll take a look at what perfect square numbers are, as well as learn about the inverse of squaring something. From there, we'll learn how to evaluate squares and square roots, including what those look like in equations. So you maybe have heard the term perfect square number before, and we're going to see why it's called that, exploring these visuals. So if we look at all of these squares, we're ranging in sides from 1 by 1 all the way up to 7 by 7. And if we think about the area of a square, or any rectangle for that matter, it's from multiplying those sides together, so like length times width. Since these are squares, both of those values are the same, so we could also write side times side or side squared. So the areas of these squares would be perfect square numbers. So 1 times 1 gives us an area of 1, 2 by 2 would give us 4, 3 by 3 would be 9, 16, 25, 36, and 49. So those numbers, 1, 4, 9, 16, 25, 36, and 49 are perfect square numbers. Now we could keep going. I'm out of room, so we'll move away from squares and more just on what these perfect square numbers are. So perfect squares are the answers or the result of squaring an integer. So what we mean by integers means no decimals or fractions, so positive or negative whole numbers. So 1 squared would come from 1 times 1. Remember, squaring something means multiplying by itself. So to calculate this, you could type it exactly as you see here, or if you have one of these calculators at home, it's this square button here. So I could press 1 and then that x squared button. The other way to do it is using the caret key. So I could do 1, that caret key right above it, and then 2 for squaring something. Or if you're on an iPhone, you'll want to turn it sideways so you get more of those buttons to pop up, but they have an x squared button on a phone calculator. So we'll just go through a couple of these. 1 squared, again, 1 times 1 would be 1. 2 squared, or 2 times 2 would be 4, and so on. I went ahead and finished up this list. So these are the most common perfect squares. Normally, it's pretty reasonable to expect you to know and recognize the perfect squares ranging from 1 squared to 12 squared. You'll start to see these more and more as you work your way through different levels of math. So again, it's more of an efficiency thing. Can you recognize these? Do you know these perfect square numbers? So maybe start quizzing yourself to try to get to know these as much as possible. So our next thing would be the opposite of squaring something, or its inverse operation. We know a couple of 2 main examples already. We know that addition and subtraction are inverse operations. They undo each other or cancel each other out. Then we also know that multiplication and division are inverse operations. So the question is, how do we undo squaring a number? It seems like it's division, but squaring means multiplying something by itself. So in order to unsquare it, if you wanted to try to use division, you'd have to know the number to divide by, which is what we're looking for. So it has its own inverse operation. Its symbol almost looks like a little check mark, and it's called the square root. So next, we're going to talk about how to find the square root, how to use it on your calculator, and how to use this to solve different types of problems. So to square root something, again, you know it by that little check mark. We need to first kind of figure out how to do this on your calculator. So the second key here is kind of like the shift button on your calculator. So if you're ever trying to take the square root, you actually press that button first, and that gets you access to anything written above the buttons. So above the x squared button that you just used to square something is that square root symbol. So you'll press second, that button, and then type your number. So for the square root of 16, again, I would type second, that x squared, and then type 16. And hopefully you did that and got an answer of 4. Or if you're on your phone, again, turn it sideways and use this button here. So the square root of 36 we see is 6. And hopefully that makes sense because 6 times 6 equals 36. So we're finding the number that multiplied by itself gives us that answer. So the square root of 49, and we're looking for what number times itself equals 49, and that would be 7. And then the square root of 121 would be 11, because 11 times itself equals 121. So we're going to start looking at how to use these in equations. And we know that inverse operations play a big role in solving equations because that's what helps us isolate the variable and get rid of whatever else is with it. So for something like x plus 3 equals 10, we're looking for what number can you add to x or add to 3 to give you 10. And hopefully you already have that answer. But if you didn't, it would all come down to inverses. So the opposite of adding 3 would be subtracting 3. That's what gets that to cancel out on this side, leaving us with just x. And then this kind of operation would leave us with our answer of 7. Same thing is true with different examples. So 4x equals 12 means what number can you multiply by 4 to give you 12? Again, hopefully you already have an answer. If not, work your way through inverses, dividing by 4, since when they're right next to each other, that means multiply, and get an answer of x equals 3. So next we're going to look at how do squares and square roots fall into these sorts of equations. So sometimes you'll see equations that have those exponents in them. So in this example, we have x squared equals 4. So to solve this, we're looking for what numbers multiplied by itself give you 4. So this would be a great time to use a square root. To undo squaring something, you're going to take the square root. And those two things would cancel out, leaving you with just x. So x is going to be equal to the square root of 4. Now if we calculate that, or maybe you know it off the top of your head, we get 2. And we know that's true because 2 times 2 gives us that positive 4 that we were looking for. But believe it or not, there's another number that works as well. Before, we've seen equations where you only have one answer, but that starts to change once we get into exponents. If we think back to our sign rules, multiplying something by itself, an example of that would be a negative number. So if we had a negative 2 times negative 2, those negatives would cancel out to also give you positive 4. So two values work to equal that positive 4 that we wanted it to. I'll erase my work here to not get confused. So we have x equals positive 2 works, but also x equals negative 2 works. So we have two answers. A couple of different ways to write this out. We could certainly just kind of make a list, so x equals 2 and negative 2. Or there's this fancy symbol that means that same thing. You see it as a plus or minus. So what this is saying is your answer could be positive 2 or negative 2. So in general, where you're solving an equation like x squared equals a number, you need to remember that there's two solutions. When I was first learning this, I like to think that the 2 here reminds me that there's two solutions to the equation. Again, you approach these just like you would a normal equation, so thinking inverse operations. To get rid of squaring something, you would square root both sides. Then you would need to remember that we have two answers. So this is the same example as the last time, kind of showing you the two different ways to write that. If we move to example B, we have x squared equals 81. So again, we're looking for what number or numbers multiply by itself to equal 81. We can take the square root, if you're not sure off the top of your head yet, and we see that that answer is 9. Again, needing to remember that negative 9 works as well. So again, the two ways to kind of write those out would be 9 comma negative 9, or that fancy plus or minus symbol. So the most confusing part is when to include two answers and when it actually only wants just one. So these two problems look very similar at first, because to solve the equation here, we would need to square root as our first step. But believe it or not, they actually have two different answers. The equation, as we learned, we're looking for what number times itself equals 121. So here we would have two answers, positive and negative 11, or again, that plus or minus 11, because both of those would satisfy that equation. If you only see the symbol, that's called the principal square root. So it's not in an equation, but instead it's given to you underneath that symbol to evaluate. Here, you would only include the positive. And if we think about why, the positive is a lot more realistic in different contexts. If you were trying to construct something and you had to take the square root, you wouldn't want to have a negative like length of a wall or something like that. So since the positive is used more often in real life and in different contexts, we call that the principal or like the main square root, and it refers to just the positive. So let's look at when we need to know how to have two answers and when to have one. Again, it all boils down to what type of problem are you solving. Two answers comes from x squared equals a number, and just the one positive comes from if you are evaluating under that principal square root. So here it says evaluate the following, square root of 16. I just see that symbol, so it only wants that positive principal square root. For x squared equals 144, I would square root both sides because of that format of the equation. Here I would include both answers, so positive and negative 12. Square root of 9 is the principal square root because it's given to me under that symbol, so this would be only the positive 3. And finally, in this last one, x squared equals 4. We've seen this now a couple of times in this video. Maybe should have mixed it up better. We have plus or minus 2. Again, you could also write these kind of in a list form. I'll go ahead and write that just in case you prefer that.